Today we're going to be talking about solving special cases. So by the end of this lesson, you should be able to solve equations such as the one given in our TEKS and understand and determine the type of solutions like infinite and no solutions. Your central question, which you'll type into the quote box there, is how can you determine the type of solution an equation has? So before we get into that, let's go over a quick review. If I had the equation -3 times x minus 1 plus 8 times x minus 3 equals 6x plus 7 minus 5x. Now our first step, if we remember, is we need to distribute. So I've got to distribute the -3 to both terms and the 8 to both terms that are behind the parentheses. So -3x plus 1 plus 8x minus 24 equals 6x plus 7 minus 5x. Our next step here is to combine like terms. And when we're looking at combining like terms, remember, don't cross the equal sign when you're combining like terms. That's when you start solving, not combining. So our like terms, let's look at our like terms. So we have an x here and an x here. And I'm picking a different color to help us remember to not cross that equal sign. These are also like terms for our variables. And then, in a different color, these constants. Oh, I made a mistake. That's what we do in math, and we learn from our mistakes. This is plus 3. These are also like terms. Remember, like terms are the same variable to the same power or constants. So, combining those like terms, that is 5x minus 21 equals x plus 7. Our next step to do is move terms. Remember, we're moving variables to one side and we're moving constants to the other. So we're moving our terms. This is where I like to circle the variables and box in the constants. And I like to move the smallest coefficient for the variable first. So I know that my circles are going to be over here, my boxes are going to end up over here. So I'm going to subtract x from both sides to get rid of it, doing that opposite operation. That gives me 4x minus 21 equals 7. Now, once again, circle the variables, box in constants. I know the only thing left I have to move is that 21, so I'm going to do opposite operation on both sides. That leaves me with 4x equals 28. And then we're going to solve for the variable. So, divided by 4, x equals 7. This is what we call a unique solution. What that means is that there is, actually, you can't really see that, I'm sorry. This is a unique or one solution. This is one of our types of solutions. And what that means is there's one specific number that makes the statement true. So when we plug 7 back into the problem, that statement, or after all of the math, both sides of the equal sign would be the same. But that is not the case all the time. So let's talk about those. If we are given the problem 9c plus 8 plus c minus 4 equals negative 5 times negative 2c minus 0.8. Now, we would solve this just like we learned how to solve with equations on both sides. We're going to distribute 9c plus 8 plus c minus 4 equals 10c plus 4. Now, I'm going to combine like terms, kind of. And the reason why I want to do that is I'm going to show you why this is one of our special cases. So I'm going to combine our c's, our variables, and the coefficients in front of them. Remember, if it's just the variable, that means there's a 1 in front of it. I'm not going to combine the constants just yet. Do you notice something about our coefficients from each side of the variable yet? What I'm going to do in this example is I'm going to go ahead and add 4 to both sides to get rid of that. Then we're left with 10c plus 8 equals 10c plus 8. Now this is starting to look like both sides of the equal sign are the exact same thing. This is what we call an infinite solution. And the reason being is if we took and we wanted to move our terms, move our variables to one side and move our constants to the other side. So if I said minus 8, that would give me 10c equals 10c. And then I could subtract 10c from both sides, right? And that would give me 0 equals 0. This is a true statement. And what I mean by true statement is that both sides of the equal sign are the same. The two numbers equal each other. Because they're the same side and they're the same on the both sides and there's no variable, we know that this means that they have infinite solutions. Any value out there, whoops, I have this on. Go ahead and circle that one. Any value that we use for c in this special case or in this equation is going to come out to a true statement. So we know that any value is a solution, meaning that there is an infinite amount of solutions. So we've talked about unique solutions and we've talked about infinite solutions, but we have one more case to look at. Let's look at negative 6 times p minus 3.2 plus 4p minus 11 plus 2p minus 8.2 equals negative 3 halves p plus 6 plus 1.5 p. Now, I know this equation looks pretty scary, but we're going to break it into our steps that we know how to do. The first thing I would do is if I have majority of my numbers are in decimal form and I have one fraction, I'm going to go ahead and convert that one number that's a fraction into decimals. In the same step, I'm also going to go ahead and, just to save some space, I'm also going to go ahead and distribute this negative 6. It's the only thing we have to distribute. So negative 6p plus 19.2 plus 4p minus 11 plus 2p minus 8.2 equals, this is the fraction that I'm going to turn into a decimal, so minus 1.5p plus 6 plus 1.5p. Now we've distributed. Our next step would be to combine like terms. So let's look at our like terms. I'm going to look through this side of the equal sign for all of my variables. Now I'll look at constants. And then go look at the other side. Oops, use that one. And I only have like terms that are variables. So let's combine the like terms. I have a negative 6p and then a 4p and a 2p. Well, 4 plus 2 is 6 minus 6. Those would cancel each other out. And same thing with our variables on this side. Negative 1.5p plus 1.5p would also cancel each other out. That would add up to equal 0. So I'm looking at 19.2 minus 11 minus 8.2 equals 6. Combining those like terms, 19.2 minus 11 would be 8.2, minus 8.2 would be 0. Those all cancel each other out, equals 6. Now, this is a false statement. And what I mean by that is the two numbers on the opposite side of the equal sign, or easier way of saying it is 0 does not equal 6. We know that this does not equal each other. So we know that 0 equals 6 is a false statement. When we see these false statements, we know that there is no solutions. No solutions. And this is our third type of solution. So we have seen unique solutions. We have seen infinite. And we've seen no solutions. These are our special cases, is the infinite and no solutions. But really and truly, most of the work that we're doing is still solving equations with variables on both sides. Now we're just looking at what happens when we get certain answers. If you have any questions, please be sure to ask your teacher or attend tutorials or something like that for additional help. And then watch the next video for practice.